Hi, in today's lesson, we are going to see forces and motion. We have a block of weight is being pulled to the right by a force P across a rough horizontal plane. We need to draw a force diagram to show all the forces. The force diagram looks like this: the pulling force, the normal reaction, the weight, and the friction. In this example, we have four forces that act on an object which is in equilibrium. And we want to find the values of the A and the B. The A and the B is the force AI plus BJ. Because the particle is in equilibrium, we make the equation equal to 0. This is the equilibrium condition. Therefore, we simplify the equation by collecting like terms. The equation becomes 3I plus AI plus 4J plus BJ equal 0. Then we factorize by taking the i's and the j's out of the bracket, and then we have one equation that is equal to 0 with I and j only. So the equation is 0 only when the coefficients are 0. So the 3 plus a is 0 when the a is negative 3. And the 4 plus b is 0 when the b is negative 4. These are the values of the a, and these are the value of the b. In this example, we have different forces, and we have an object that is accelerating. On the first example, the acceleration is to the right. In the second example, the acceleration is to the left. And we need to find the magnitude of the unknown forces. Because the object is accelerating, there's a moving, we have this equation. According to Newton's law, the sum of the forces are equal to the mass times acceleration. So by considering the first example, the movement is horizontal, therefore the vertical forces are 0. So let's start from the horizontal forces. The horizontal forces are the plus x minus 4. And we make this equal to 2 times the 2, the mass times acceleration. Therefore, the x force is 8 newtons. By the same way, I can find the vertical forces. Because there is no movement vertically, we make the vertical forces equal to 0. They need to balance each other. So we have the other equation must be y minus 2g is equal to 0. Therefore, the y force is 2g newtons. The same we do for the second example. Here acceleration is to the left. The horizontal forces are the x and the 80 newtons only. Because acceleration is to the left, we make positive the force that is going to the left. So the first equation we prepare for the part B is 80 minus x. And we make this equal to the mass 4 times the acceleration 2. This equation gives you the value of the x force. This is 80 minus 6 minus 8, so this is 72 newtons. Now the vertical forces must be 0 because movement is horizontally. So we make another equation, but make it the sum of the forces 0. So the y minus 20 minus 4g is equal to 0. So the value of the y is 20 plus 4g newtons. And we found the forces. In this example, we have a resultant force 3I plus AJ that acts on a particle of mass 0.5, and we want to find the acceleration of the particle as a vector. Since the object is moving, we start with the equation F equals ma. The resultant force is the 3I plus AJ. We make it equal to the 0.5 times the A. Therefore, dividing both sides by 0.5, we have the acceleration vector as 6I plus 16J. We can also draw a diagram by drawing a vector starting from the origin and towards the point 6, 16. And you see the diagram on the left. This is the acceleration vector. To find the magnitude, this is equivalent to the hypotenuse of this right-angled triangle. So we can use Pythagoras theorem and find the hypotenuse of this right-angled triangle, which is 6 squared plus 16 squared. So the acceleration is the square root of 272. To find the bearing, we need to see that the bearings, we need to measure the angles clockwise from the north line, from the J-axis. Therefore, the angle that we need to find is this angle that is shaded with green color. To find this angle, we may use the other right-angled triangle and use a trigonometric function. For example, if this angle is theta, then the tan theta is the opposite over adjacent, so it's 6 over 16. Taking the inverse, the tan inverse tan of 6 over 16 is the angle 20.6, and this becomes the bearing of the acceleration, 20.6.